All right, our final lesson of Unit 4 is on isosceles, equilateral, and right triangles. Of course, as always, when I finish and you finish, you need to come back up here and fill in your essential question, and at the end, write yourself a little summary. You already know a lot about isosceles, equilateral, and right triangles. You definitely know what they are. So we're going to learn a few new theorems, and then of course most of the lesson will be spent practicing a couple of proofs. All right, here's some terminology you may not know. The two angles adjacent to the base of a triangle are called the base angles. So if we look at this triangle right here, these would be the base angles, meaning this would be the base. All right. And the angle opposite the base, so that would be this one right here, opposite the base, it's called the vertex angle. So that angle is going to be the vertex angle in this triangle. All right, so we have a theorem that has to do with isosceles triangles. It says if two sides of a triangle are congruent, of course we know that means it's an isosceles triangle, then the angles opposite those two congruent sides are congruent. So if I have this labeled as A, B, C, okay, and if side AB is congruent to AC, then I know that angle B is congruent to angle C. You will use that quite a lot in geometry. And then of course there's a converse of that. The converse would be that if I know those two angles are congruent, then I know the sides opposite them are congruent. So once again, ABC, if angle B is congruent to angle C, then I can say that AB is congruent to side AC. So that's the converse of the base angles theorem, or as this textbook calls it, the isosceles triangle theorem. All right, here's another little theorem that you will find useful from time to time. If a line bisects the vertex angle, let's go ahead and label this one. If a line bisects the vertex angle, so we're just going to go ahead and draw this as our line. And if it bisects it, then what does that do? I know it makes those two angles congruent. If I know I have an isosceles triangle, so I would already have to know that these two sides are congruent, right? Because it tells me in this theorem I got an isosceles triangle. So this line bisects the vertex angle, then it is also the perpendicular bisector of the base. Okay, perpendicular bisector of the base, that would mean that is congruent to that. So let's write it this way. And let's call this D. Let's call this point right here D. So if DA, and they call it a line in there, so I'll write it as a line. It could be a segment, it could be a ray. So if DA bisects angle BAC, and we got to know this, triangle ABC is isosceles. We have to know that to apply this theorem. And what does this theorem tells us? What does this theorem tell us? It tells us that angle ADC and angle ADB are right angles. I know that because of the definition of perpendicular lines, right? So I'm leaving out some steps if this were approved, but I'm just trying to summarize this for you. All right, ADC and ADB are right angles, and that line also bisects the base, so BD is congruent to CD. So that little theorem tells us a whole lot. If I got an isosceles triangle, if there's a vertex angle bisector, then that line that bisects that vertex angle is also the perpendicular bisector of the base. All right, we're going to talk about a corollary. I think we may have already talked about corollaries, but I couldn't remember, so I put this little line in. A corollary is a theorem. So a corollary is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as a reason in a proof. So I'm thinking we might see some corollaries here coming up on the next page. Yeah, we got the base angles corollary that says if a triangle is equilateral, then it is equiangular. So if I got an equilateral triangle, A, B, C. So if I know that's equilateral, then what do I also know? I know that angle A is congruent to angle B is congruent to angle C, and hopefully you would know that all their measures are 60 degrees, right? Okay, and how about the converse to that corollary? So it's just the flip. If I know that the triangle is equiangular, then I can say it is equilateral. Okay, here's a new little theorem for you. It's the hypotenuse-leg congruence theorem. We abbreviate it with HL, so when you use it in a proof, all you got to put down is HL. And it says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, and of course they both have to be right triangles, then the two triangles are congruent. So if BC is congruent to EF, and AC is congruent to DF, then triangle ABC is congruent to triangle DEF. So that's another way I can prove congruent triangles, not using side, 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 angle, side, angle, or angle, angle, side. All right, what you got to remember though, three conditions must be met. That's what that was supposed to say. If I'm going to use the HL theorem, triangles have to be right triangles. So in your proof, before you use this theorem, you're going to have a statement somewhere that says your triangles are right triangles. The triangles' hypotenuses have to be congruent. The triangles must have one pair of congruent legs. So before you can use the HL theorem, you're probably going to have those three steps somewhere in your proof. Okay, let's do a little practice here trying to figure out the values of x and y. Let's see what we got here. We know that all these sides in these triangles are congruent. So I know that this angle right up here would also measure y degrees, right? Because it's got to be congruent to that one by the base angles theorem. This angle right here also got to be 70 degrees by the base angles theorem. I don't see an x in this picture, so maybe we only got y here. All right, so what have I got to do now? Well, let me fill in what else I know here. I know that this is 110 degrees, right? 110 degrees right there by the linear pair postulate. Oh, I see now. So if this angle up here and this angle are congruent, then what I can say is that y plus 110 has to be 180, right? Because if the sum of these two is 2y, then I know that's 180 minus 110, which is 70, so y has to be 35. That's how I go about that one. Okay, what do we got here? We got another isosceles triangle. These are my congruent sides. Therefore, I know my base angles are congruent. So 75 equals 5x. Base angles theorem. So 15 equals x. That's one part of my question. And then I got to figure out what y is. So if each of my base angles is 75, then the sum of those together is 150. So I got 150 plus 3y has to be 180, right? Triangle angle sum theorem. So 3y is 30. So that's going to tell me that y equals 10 for that triangle right there. And finally, why don't you do this one? I'm going to pause, you do it, we'll be right back. Okay, what I had to do first here, or at least the way I started, is because these two sides are congruent, then I know that both of these angles are y degrees, so I labeled that as y there. And then I want to find what the measure of this angle right here is, because I know the sum of all these three together is going to be 180 degrees. So that's my equation I set up right here. 60 plus 70 plus A, I just called it angle A, is 180, and that led me to know that this angle right here is 50 degrees. And then, given that, I know that 50 plus 2y is 180 degrees by the triangle angle sum theorem, and so I solve for y and I get 65. And then finally in this triangle, since these two sides are congruent, I know this angle right here has to be congruent to the other base angle, so it's 70 degrees. So therefore the sum of all the angles is 180, and I subtract the 140 and I get that x, this angle right here, is 40 degrees. Okay. All right, we got another proof here. Let's see what we have. Statements. Reasons. RV is congruent to ST. Angle RTV and SVT are right angles. That's all given. And I'm trying to prove that triangle RTV is congruent to triangle SVT. So, I got right triangles. I know the hypotenuses are congruent, so it looks to me like all I really need to do is get a set of corresponding legs that are congruent, and I can do that because this leg right here is shared between the two, so I think this is going to be a fairly simple matter. Don't forget though, I have to say, now in this case, typically in a proof, if they give me that two angles are right angles, I would want to say that those two angles are congruent. But I only need to do that if I'm going to use side angle side, or angle side angle, or angle angle side. If I use HL, I don't need to say that any of the angles are congruent. What I do need to say is that triangle RTV and triangle SVT are right triangles. Remember, that was one of the conditions on the previous page we said had to be met before we could use HL. So, and how do I know that? That's the definition of a right triangle. A triangle that contains a right angle. Definition of right triangle is how I know those are right triangles. Okay, and now all I need to say is that TV is congruent to VT by the symmetric property of congruence. Right? And now I have it, right? I have a leg, I have the hypotenuse, so I can go ahead and say that triangle RTV is congruent to triangle SVT by the HL theorem. All right, simple enough. Okay, we're going to do these next three problems, and then all that's left in the lesson are two more proofs, and I'm going to save those for you, and they will be extra practice for you. If you want to talk about them in class, then please bring it up, and I'll be glad to do them with you. So what we got to do here in 4, 5, and 6 is decide whether we have enough information to prove that triangles are congruent. So let's see what we have here. Triangle, let's see, number 4, well, we know that both triangles are right triangles, right? And we know that we have congruent hypotenuses, and we know that we got a congruent leg because it's shared by the two. So yes, we do have enough information. It says to explain our answer, so I pretty much just did that. So I'm going to say, since the triangles are right, and the hypotenuses and a pair of corresponding legs are congruent, we can use the HL theorem to say that those two triangles are congruent. And let's just go ahead and write our congruence statement. That's not a bad idea to practice that. Triangle RST here is congruent to triangle RUT. Okay, how about these two? Let's see what we have. Looks like these two triangles here, triangle ABC and triangle DCB, right? So I'm trying to figure, what have I got? I got an angle, I got two sets of corresponding angles, and look guys, they share a side. So yes, I could definitely use angle, angle, side to show that these two triangles are congruent. What I would have to do is I would have to say angle B is congruent to angle C by the right angles theorem. And I would have to say BC is congruent to CB by the symmetric property, and therefore by angle, angle, side, triangle ABC is congruent to triangle DCB. All right. How about these two? Let's see. I don't have anything given to me congruent, but I do have some parallel lines. So let's see. I could say this angle is congruent to this angle, right? If these are my parallel lines. And DT would be my transversal. Those would be corresponding angles. And let's see. If these are my parallel lines, and this is my transversal, I could say that this angle is congruent to this angle, right? But what I don't have, they're definitely not right triangles. I don't have any sides that I know are congruent, so I don't have enough information here. So do not have enough info here. I promise you on your quiz, well, we're past the quiz, on the test, more than likely you'll see some more of these. Probably saw some on your quiz already. I'm giving you triangle sets and you're going to have to tell me, is there enough information here to prove that these are congruent? You don't actually have to do the proof, but you have to think through it and decide if there's enough information. Okay, I'm going to hold off on these two proofs. We're already at 18 minutes on this lesson and I don't want to go too long, but I would like for you to spend maybe the next 12 or 15 minutes and see if you can complete the last two proofs in this lesson. I'll put the solutions up for you. See you next time.